Hello everyone, I welcome you all, and in this video we are going to discuss the numerical from your unit number 1, that is vector analysis. And this numerical is basically related with the coordinate system transformation. Okay, so we will begin with that one. So if you have any queries, you can drop me a mail onto my this email ID. Now we will start with the given numerical. Now, if you look out with this, what is given to us, so you can see that whatever is your given vector A, that is expressed in terms of rho, phi, and z. So that means what? Your given vector is in the cylindrical system, and we have to convert that cylindrical system vector into its Cartesian coordinates or Cartesian system. So how it can be done? So before moving on to that one, if you have seen my previous videos, you can see over there we have to make use of some convergent table. So here in this case again, we are going to make use of the convergent table in order to convert this cylindrical vector into a rectangular vector. Okay, so what is that table and what are its respective values that we will see now? Okay, so the convergent table in order to convert your Cartesian system into cylindrical one and vice versa. That means you can convert the cylindrical system into Cartesian coordinates. So this is the convergent table that we will be using. So this is very first, that is dot, and that dot indicates you what? The dot product in between the components of Cartesian system or rectangular system. So what are that components? For your Cartesian or rectangular systems, we have the components AX cap, AY cap, and AZ cap. So these are the three components of your Cartesian system. And what are the components of cylindrical systems? We have that to be a rho cap, a phi cap, and a z cap. So as we have seen earlier in the previous video, what is the dot product in between that ax and a rho? We have that value to be cos of phi. Now what is dot product in between ay and a rho? That is equals to sine of phi. And dot product in between that az and a rho is equals to what? That is 0. Now, what is the dot product in between this ax and a phi? So we have that value to be equals to minus sine of phi. Dot product in between ay and a phi is equals to cos of phi. And dot product in between az and this a phi, that is equals to 0. Now, the dot product in between the two different vectors from the property of the dot product. What will be that one? Ax dot az is equals to, we have that to be 0. Ay dot az is equals to what? We have that is to be 0. And dot product in between the two same vectors, that is az dot this az. So we have that value to be equals to 1. So we will be using this transformation table. Besides that, we also have to make use of the values of that x and y and z. So, since we are given this into the cylindrical system, that we have that rho, then this x is over there. Okay, fine. So we have this rho, then phi, and then z. So what is the rho that we have with us? So we have that rho is equals to square root of x square plus y square. Then we have phi. Phi is equals to what? Phi is equals to tan inverse of y by x. We already know about that one. But if you see over there, we are not going to make use of this one. Okay, instead of that, what we will be using, we will be using this one, that cos phi. As we are going to move further, you will see that one. So we are going to make use of this cos of phi. This is new to you. If you have seen my earlier videos. So cos phi is equals to what? Square root of sorry, x divided by square root of x square plus y square. Now you might get confused how this come over there. Now if you have gone through the cylindrical coordinate system, we have this, that x is equals to, we have x as rho cos of phi, Okay, fine. Now from this one, what you can get from this one? Cos phi will be what now? Cos phi will be x divided by rho. And what is rho? We have this one. So x divided by rho value is what? Square root of x square plus y square. So this is how you are going to get the value of the cos of phi. This is for your information purpose. So well, I hope you have got this conversion. Okay. Now in similar fashion, we can write what is value for that sine of phi. So now I'm going to rub it out. Before directly writing for that sine of phi value, let me show you the proof. So for cylindrical system, we have this y is equals to rho sine of phi. So from that you can get the value of sine phi. And what is that sine phi? We have that sine phi is equals to y upon rho, and that y is equals to what now? Sorry, not y exactly. So what will be that sine phi now? So sine phi will be y upon value of rho. And what is that value? So we have that rho is equals to square root of x square plus y square. Okay. So this is what we are going to use within this numerical. So we are going to make use of this cos phi is equals to x divided by square root of x square plus y square, and that sin phi is equals to y upon square root of x square plus y square. So this is what we will be using throughout this numerical. Now we will begin with our numerical. Okay, fine. So well, I hope you have taken the screenshot of this one, and for your reference purpose, I'm also going to keep it onto the one side of the slide. Okay, so this is what we are given with. We are given with vector A, which is expressed in terms of that rho a square plus 1 a rho cap minus rho z cos phi a phi. Now, if you want to express this given vector A in terms of Cartesian system, so it can be expressed like this. So your vector A will be what now? Uh, Ax cap, Ay cap, Az cap. So these capital Ax, Ay and Az, they shows you what? Magnitudes along x, y and z direction. Okay, now we will start to find out the magnitude of that Ax. Now what is that one? If you have seen my previous video, so this Ax, that is magnitude of that given vector in x direction. So it will be shown like this one. So magnitude along x direction is what? Given vector A, projection of given vector A in the x direction. Okay, so now we are going to rewrite that given vector A. So what we have given vector A? So that is rho into x square plus 1, then a rho cap minus rho z cos phi a phi cap, having the dot product with what? Having dot product with x cap. So for now we will keep the things simple so that it will not get mess up. So very firstly we are just going to have the dot product in between this a rho and ax and a phi and ax. Okay, so we will keep that one as it is for now. Rho into x square plus 1 into this dot product of a rho and ax. So what is that one? Dot product in between a rho. Now here we will go like this in this fashion. Okay, so dot product in between a rho and ax. So what is that one? We have that to be cos of phi. So dot product in between a rho and ax is equals to what? We have that value to be cos of phi. Now keep the values of that rho and z as it is for now. Rho z cos phi, it is as it is. Now we have to find what is the dot product in between a phi and ax. So what is that dot product in between a phi and ax? So here is that one. Dot product in between this a phi and this ax. What is that one? We have that to be minus of sine phi. So if you are going to put that minus sine phi over there, okay, so for your reference purpose, I am going to put that one. If you are enough confident with that confidence that your calculations, so you can directly write that one. So here we are going to say it to be what? Minus of sine phi. Okay. Now if you rewrite this one, so what we have? Rho into x square plus 1 into cos of phi, and this minus sine phi into this minus term. So that will be what now? Plus rho z cos phi sine phi. Okay, now we have this one. Now what in the next step, what we are going to do? We are going to put the values of that rho, x and z over there. Okay, so in the previous slide, what we have seen, what is the value of that rho? We have that rho is equals to what? Square root of x square plus y square. Now we have that x square. So keep that one as it is for now. Keep that one as it is since it is already in Cartesian system. Now we have the cos phi. So what is the cos phi that we have derived in the previous slide? So we have that cos phi is equals to x upon square root of x square plus y square plus now again rho. So what value we have for that rho? So we have rho is equals to what? Square root of x square plus y square into this z is as it is since it is already in Cartesian system. Now put the value of that cos phi. So we have the cos phi is equals to what? X upon square root of x square plus y square and this sine phi. So sine phi we have from the previous slide, that value is equals to what? Y upon square root of x square plus y square. Okay. Now if you see this one, so this square root of x square plus y square and this square root of x square plus y square, it will get cancelled out. Now here in this case, this and this, it will get cancelled out. Okay, so what is left? So very firstly, we have from this simplification that it is equals to what? X square plus 1 into x plus this and this get cancelled out. So what is left over here? This x, y and z. So we are going to rearrange that one. That is what? X, y, z divided by square root of this x square plus y square. So we have the very first element and that is what? That is the magnitude of your given vector in the x direction. So assign some equation number to that one. So here in this case we are going to assign it with equation number 2. That gives you only the magnitude along the magnitude of vector A in the x direction. Now in similar fashion we are going to get the value of magnitude of AY. Now next element that we are going to find is what? Magnitude of your vector A in y direction. So what it will be? It will be projection of vector A in the AY direction. So this is what? Okay. Now again rewrite that given vector A. So we have that given vector A is equals to rho into x square plus 1 A rho cap then minus rho z cos phi A phi cap having the dot product with what? Dot product with AY cap. Now we are going to have the dot product. So this keep this as it is rho into x square plus 1. Now what is dot product in between a rho and ay? So you can refer this table. So dot product in between this a rho and ay is equals to what? Sine of phi. So keep that value as sine phi. Now this rho z cos phi a phi. So a phi dot ay is equals to what? This a phi dot ay is equals to we have cos of phi. So this is cos of phi. Okay, now we are going to put the values of that sin phi and rho over there. Okay, so what we have for that rho? We have rho is equals to square root of x square plus y square into this x square plus 1. We have sin phi. So sin phi value, what we have for that sin phi? You can refer the previous slide, and we have that sin phi is equals to what? Y upon square root of x square plus y square minus, again we have rho is equals to what? Square root of x square plus y square. Z is as it is, since it is already in Cartesian system, cos phi. So cos phi, what we have cos phi? We have cos phi is equals to x upon square root of x square plus y square, and this cos phi again. So we have that to be x upon square root of x square plus y square. Okay, now we are done with the putting the values. So we will see what will get cancelled out. So here in this case, this square root of x square plus y square and this square root of x square plus y square, it will get cancelled out. Here in this case, this one and this one get cancelled out. So what we have? What is left? So we are left with this. If you are going to rearrange that one, so we have that y into x square plus 1, then this minus this x into x square, and then this z. So we have that to be equals to what? X square z divided by that square root which is left over here, square root of x square plus y square. Okay, so this is what? This is the magnitude of given vector A in the y direction. Sorry. So this is your magnitude of vector A in y direction. So assign some equation number to that one. So let's say this is equation number 3. Okay, now we will see what is there for your AZ component. Now if you see this given vector A, so you will find that it is given with only two components, that is component along arrow direction and component along phi direction. So it is there that we have that 0 AZ component. That means there is no AZ component over there. So that's why we are not, it is not necessary to find out that AZ component. So from the given vector A, we have that AZ, that is magnitude of vector A along z direction to be with value of 0. So this is what? This is your third component. For that, your this given equation number 1. We have found this AX, we have found AY, and we have also found that AZ. So assign some equation number to this one. So this is what your, I guess, equation number 4. Okay, so what we are going to do? We are going to combine your equations 1, 2, 3, and 4. From this, we get, or we can express given vector A in terms of cylindrical system. Sorry, no, not cylindrical, in Cartesian system, and your vector A will be what now? So put the values of that AX. So what is the value of AX that we have found from the previous slide? That AX, we have x into x square plus 1 plus xyz divided by square root of x square plus y square. So this is what magnitude along x direction having component as cap from here. This is your reference. Now plus what is the magnitude of that ay component? So we have from the previous slide that to be y into x square plus 1 minus x square z divided by square root of this x square plus y square. So this is what your magnitude along y direction having this component, that is ay cap, and we have that az is equals to 0. So that's why we are not going to write your az component. So this is what your given vector A, which was already given in terms of cylindrical system, and we have expressed it in terms of Cartesian coordinate system. So this is your final answer. Okay, now you can hit the like button if you appreciate my efforts. Okay, thank you.